In 2020, Elon Musk confidentially declared that his company would land the first human on Mars by 2026. It's now 2024. From what we can see, Musk hasn't had any luck, and with just 2 years remaining until his predicted date, the prospect of seeing a human on Mars is, to put it mildly, unlikely. Meanwhile, NASA seems to be in no hurry. They are just now planning missions to the moon again. But even these missions are constantly being postponed. So what went wrong? In this video, you'll learn, why is it so hard to travel to Mars from Earth? Why have we already traveled to the moon but not yet to Mars? How and when is it planned to travel to Mars? How are we going to conquer Mars? Please like this video and subscribe to our channel Dark Core for more fascinating educational, music, content. What does conquering Mars even mean? For most people, this means, at the very least, to have a person fly there and plant a flag, or to build a base with regularly rotating staff like on the ISS, or even to terraform Mars, that is, to deliberately change a condition so much that it would resemble life. Whatever people dream about, for now even flying there and planting a flag is an extremely challenging task. It would be a great achievement if the first interplanetary astronauts managed to reach the red planet and successfully return to Earth. Successfully means alive, and preferably more or less healthy. But why is it so difficult? After all, people went to the moon several times more than half a century ago. Because sending a person to Mars is, to put it mildly, not the same as going to the moon. This task is incomparably harder. And now we'll show you just how vast this difference is. Let's take a step back to fully comprehend this. A human first set foot on the moon on July 20th, 1969. And this wasn't a symbolic mission just to plant a flag. People worked there. There were 6 manned missions in total, and 12 people were lucky enough to walk on its surface. It took just 7 years from the goal's announcement in 1962 to the landing of a human on the moon, which is incredibly fast. The question is, what's wrong with Mars? Why hasn't a single person been there in more than half a century? Despite all his optimism, even Elon Musk said in an interview with entrepreneur and space adventurous co-owner Peter Diamandis, "Honestly, a bunch of people will probably die in the beginning. Honestly, a bunch of people probably won't die in the beginning. It's tough sledding over there. You know, we're an exploring species." So what makes it so difficult? Imagine that you need to walk to a shopping mall 1 kilometer, about 0.6 miles, away from your home, and back. It would take you about half an hour, or you could comfortably make the trip in slippers. And you probably wouldn't get very tired. You certainly wouldn't need to bring sandwiches to have a snack on the way. Now imagine having to walk not 1 kilometer, 0.6 miles, but 140 kilometers, 87 miles, plus the same distance back. That's more than a beeline from New York to Philadelphia. Keep in mind that this route would go through uninhabited terrain with no roads, stores, or people. A regular person wouldn't be able to cover this distance in a day or two. If there are no stores along the way, you'd need to carry food, water, medicine, tools, and a raincoat, sleeping bag, and a tent, because there would be nowhere to buy supplies on the way. If such a traveler breaks a leg halfway, then they are almost certainly doomed. This is roughly how a flight to Mars compares to a flight to the moon, only many times worse. The distance to the moon is stable, 384,000 kilometers, about 238,857 miles, while Mars is at least 56 million kilometers, about 34.8 million miles, away, which is about 140 times further than the moon. This is a minimum value, because this distance constantly keeps changing, given that planets orbit the sun at different speeds. At some point, Earth and Mars can end up on opposite sides of the sun. Then the distance will reach 400 million kilometers, about 248.5 million miles. That's 1,000 times farther than the distance between the moon and the Earth. In our example with a hiker, this is like walking from New York to Chicago. Mind you, all of this is on foot, and we emphasize on foot for a reason. Considering the size of our solar system and the universe as a whole, current human space travel is almost snail-paced. With modern technology, a one-way flight to Mars will take 7 months, or even nearly a year. That's because of the distance. The enormous distance is the main issue with a manned mission to Mars, and all other problems come from it. There are plenty of those problems too. During all these months, the crew needs to eat and drink, keep their bodies clean, monitor their health, and perform many daily tasks. They also need to get along with each other in a confined space. All this would happen in a setting with numerous threats, breakdowns, cosmic radiation, and no chance of receiving help from Earth. Even getting simple advice from specialists on Earth will be delayed by 10 or even 20 minutes, depending on the current distance. Can we somehow assess in advance the likelihood of such a mission's success? Well, see for yourself. In over 60 years, 48 missions have been sent towards Mars, including those that didn't even involve landing a probe or rover. Of these, 26 failed. Even the chances of an unmanned mission success are almost 50-50ths. See, even unmanned. Considering all of this, Elon Musk's words about the likely deaths of the first Mars explorers sound frighteningly convincing. And keep in mind that this is coming from Musk, who is widely known for his optimistic take on Mars exploration. But no matter what, humanity does not intend to give up. Therefore, we will stop pessimistic thoughts for today and move on to how the optimists plan to get to Mars. Let's take this journey along with them. First, we'll see how NASA, the most iconic space agency in the world, sees this. So the first problem is actually taking off, getting out of Earth's powerful gravitational pull. Now, this all depends on how much equipment needs to be taken along. Take a look at this space shuttle that performed manned missions to Earth's orbit. It's a huge rocket, 56M, about 183 feet long, but even it looks like a toy compared to the Saturn V that delivered manned missions to the moon. One can only imagine what a monstrous rocket one would need to lift all the enormous supplies and equipment required for an Earth-to-Mars mission. To get this into perspective, let's go back to our example with the hiker from the start of the video and complicate it a little bit. Imagine you need to walk those very same 140 kilometers, about 87 miles, through uninhabited terrain with a full supply of food, water, and everything else in your huge, heavy backpack. And now here's the kicker. The path will be off-road but on flat terrain. However, the first kilometer must be covered on a very steep slope. So steep that you might not make it to the top. And even if you do, you might collapse at the top, unable to go any further. This roughly describes a scenario of starting a mission to Mars directly from Earth. It's almost impossible to build a rocket that can lift a giant load in one go, fly to Mars with it, and then return, not to mention landing people on the surface. That's why NASA decided that the first manned mission to Mars won't start from Earth. It makes much more sense to start from a place where there is no strong Earth gravity. Currently, the most accessible option for humanity is to transport all the necessary spacecraft parts, fuel, and cargo to orbit in several launches, assemble everything there, and then start the mission. However, NASA decided to go one step further by building a base on the Moon and, simultaneously, a space station in lunar orbit. The idea is that if the spacecraft is launched from space where there's zero gravity, it wouldn't be such an insurmountable task to start the mission to Mars. The station itself can be built in several stages, as the task can be broken down into parts. This is like in our example with a hiker. First, you'd run several times up the mentioned slope to carry provisions, water, and everything else during several trips. You'd then store it all in a simple hut built in advance, and only then set off with a heavy backpack, but on flat terrain. Actually, this is a very serious program that has been in development for several years. It's called Artemis, and there's already been a successful flight within its framework. No, we haven't missed anything. People haven't returned to the moon yet. But humanity is now closer to this goal than it has been in the past 50 years. The Artemis program includes many stages. So far, only the first stage has been successfully completed. In November 2022, NASA launched the SLS rocket, which was designed based on technologies of the Saturn V rocket and reusable space shuttle ships. It delivered the Orion spacecraft to the Moon, which was sent without a crew for the first mission. It orbited the Moon and safely returned to Earth. This was the Artemis I mission. Artemis II will follow the same route, but with a crew in September 2025. According to the plan, astronauts will fly to the Moon without landing. During this mission, they'll confirm that all spacecraft systems are fully functional in deep space conditions. The flight is expected to take 10 days, which includes orbiting the Moon. The Artemis III mission will involve landing astronauts on the Moon for the first time in half a century. The Orion spacecraft is not designed to land on the Moon, so the lunar spaceship module developed by SpaceX will be used for this task. Orion and the Lunar Starship module will meet in lunar orbit. Then the astronauts will transfer to the Lunar Starship for the descent to the lunar surface. The astronauts will spend about 7 days on the Moon, exploring the South Pole region and establishing base. This mission will set a record for the longest human stay on the Moon, surpassing the 72-hour mission of Apollo 17. The internal volume of the Lunar Starship module would provide much more comfort compared to the Apollo mission vehicles. During the mission, 2 astronauts will conduct several moonwalks, performing various scientific observations, including collecting samples of water ice. Let's try to look even further into the future, when the red planet will be within our arm's reach, in every sense of the word. During Artemis 4, the active stage of constructing the Lunar Gateway Station will begin. This orbital station will go around the Moon and serve as an intermediate point for missions to the lunar surface and eventually to Mars. The first step is a launch of 2 key modules of the future station, the Power and Propulsion Element, PPE, and the Habitation and Logistics Outpost, HALO, on the Falcon Heavy rocket, scheduled for 2027. They'll be sent into space in a single cluster. It will take approximately a year for the modules to reach their target orbit. After completing all necessary checks, the Dragon XL supply ship will be launched to the Gateway, following the docking of the Lunar Starship, which is designed for landing astronauts on the Moon. After this, the station will finally receive its first visitors, the astronauts of the MES 4 expedition. What will happen next up until the 11th mission? It will be a complex and exciting yet somewhat routine process. Under the MES program, astronauts will build and improve the orbital station mission after mission. They will establish a lunar base on the Moon, develop lunar infrastructure RURA, and run countless test experiments and trials. The objective will be varied, but the primary goal for all of them will be preparing for a mission to Mars. The 11th MES mission is the last one that NASA has officially announced its schedule for 2036 or further. We'll look into the future, the less specific details we have even from official sources. However, we'll still piece together all the data, all the plans, hypotheses, concepts, and expert opinions to show you the likely course of events, while MES missions 4 through 11 will primarily focus on the developing infrastructure on the Moon and its orbit. Starting with the 12th mission, the vision of the main goal, the future Mars flight, will start to come into focus. Let's imagine how this might unfold. Now let's envision Artemis 12 first and foremost. For most astronaut teams will work on and streamline technologies for obtaining water and oxygen from readily available sources, essentially lunar mineral deposits. Of course, this doesn't mean turning rocks into water. It means finding ways to efficiently process deposits of lunar ice. For this, geological studies will be conducted on the Moon to search for and extract resources, including water ice reserves. By the way, if you want to get ahead of things, oxygen can also be extracted on Mars and not necessarily from water. Recently, the Perseverance Mars rover successfully proved this. It utilized MOXIE Mars oxygen in situ resource utilization experiment, a kit designed to experiment with extracting oxygen from the carbon dioxide in Mars's atmosphere. So the prospects are promising, but let's return to the Moon. What else can be done there to prepare us for a mission to Mars? During Timus 13, astronauts will likely refine the rapid construction technology. These technologies will be essential for long-term lunar missions, so they'll have to be developed on the Moon first and then transferred to Mars. For this, NASA is exploring innovative approaches. The agency is seriously considering 3D printing as a technology for creating habitats on the Moon and Mars. In 2020, it signed a contract with Icon, a company specializing in innovative construction technologies. The idea of using lunar IGF for building bases and protective structures using 3D printing technology is also being considered. Analog missions will be a crucial component of the subsequent program missions, starting with Artemis 14 and continuing through Artemis 20. NASA will conduct analog tests on the Moon to evaluate the capabilities of future Martian habitat capsule suits and life support systems. NASA plans to use efficient surface power system to generate energy on the Moon. This is a pinnacle of engineering, a power plant capable of converting the energy from uranium atom fission into electrical energy. Essentially, it is a compact nuclear reactor. This system will power the lunar base, providing a stable and reliable energy supply. Several such systems will be implemented so that one system can replace another in case of failure, ensuring the base's additional protection and stable operation. The power output of one nuclear energy system will be 40 kilowatt. Astronauts will also test and develop advanced life support systems. They'll grow plants in special greenhouses and use microbes to recycle waste. The recycling process will produce oxygen and food. For instance, astronauts will be able to use lunar soil and hydroponic setups to grow vegetables, and microbes will help convert organic waste into fertilizers for plants. Astronauts will study the effects of low gravity and radiation on bone mass, as well as The impact of living in confined spaces on mental health telescopes will be installed to observe space without the interference of Earth's atmosphere by the 20th mission. NASA and his partners will have developed the lunar infrastructure enough for astronaut teams to stay there permanently and feel at home. Then we'll take a historic step that will make the red planet much more accessible and the plans for its colonization much more realistic. We are talking about the construction of the first orbital Martian station in history. Lockheed Martin, the corporation that created the Man Orion spacecraft, presented the Mars Base Camp project in 2016. The concept includes a Martian orbital station that can accommodate up to 6 astronauts. Having a station in Mars orbit will significantly accelerate the process of actually traveling to the red planet. However, before attempting to land on Mars, some conditions must be established for the first explorers. According to NASA's plans, a conquest of Mars will be carried out in 3 stages. So stage 1, some equipment will be brought to Mars in advance before humans arrive. These units will be initially delivered from Earth to the lunar station, and from there to Mars. It is likely that the fission software power system will be deployed on the red planet. Several of these systems will be dropped on the surface. They are the ones that will make the future Martian base energy autonomous and independent of sunlight. Otherwise, any prolonged dust storm could cause significant issues. In addition to the fishing surface power systems themselves, fuel supplies and equipment of fuel transfer will be sent to the planet in advance. According to the approximate estimates, the total weight of the essential cargo will be tens of tons. This is orders of magnitude more than any automated mission to Mars ever undertaken. To put this into perspective, the weight of the most advanced and heaviest rover, Perseverance, is just over 1 ton 2,260 according to NASA's concept. Special heavy-duty cargo landers designed to carry 25 tons will be used for such cargo missions. Cargo landers are spacecraft designed to deliver goods to other planets or moons. In the second stage, a special module called the Mars Ascent Vehicle (MAV) will be sent to Mars's surface. This vehicle is designed to bring astronauts back to Mars's orbit. It will be a relatively compact structure equipped with rocket engines capable of overcoming Mars's relatively low gravity and carrying people and cargo into orbit. Finally, in the third stage, astronauts will fly to Mars from the lunar station aboard the Deep Space Transport spacecraft equipped with a Transit Habitat module. The Transit Habitat is a living module that provides astronauts with sleeping quarters, work and rest areas, air and water regeneration systems, and radiation protection for long space missions. It will take 10 months to reach Mars, and 2 people will descend to Mars, while 2 remain on the orbital station. The astronauts will use a specialized landing module to descend to the planet's surface. This module will be delivered to Mars's orbit and ready for use when the crew arrives in orbit. Essentially, this will be both a vehicle and a home for the astronaut. NASA's idea was to combine the first Martian home and transport vehicle into one rover equipped with an air supply system. This is all about optimization to reduce the number of items needed for landing on the surface. The agency has been working on creating this rover for a long time and has even conducted extensive prototype testing on Earth. In the SEAL rover, which resembles a van, there will be everything the astronauts will need to live and work for several weeks. They'll be able to travel around Mars inside it wearing comfortable clothing instead of bulky spacesuits, which they'll only need to wear outside the vehicle. This futuristic-looking machine will be designed for 2 to 4 crew members. The rover will have several functional compartments, including medical, exercise, and storage areas, as well as a gallery and crew cabins, life support systems, and the environment will be designed in general 30 to 60 days of fully autonomous operation. After landing on the red planet, the astronauts will conduct research naturally. They'll take numerous soil samples. Okay, we figured out the astronauts descend to Mars, but how will they get back into space and return home? Here's how it's going to happen. Having collected Mars samples, the crew will fly to the planet's orbit on the MAV, which was sent to the red planet. During the second stage, the crew will spend about 2.5 Martian days, around 60 hours, traveling to the orbital station, where the deep space transport with a Transit Habitat module will be pre-docked. After docking, the crew and cargo will transfer to the Transit Habitat, and the MAV will be discarded. Next, the deep space transport will set out for a long trip back to Earth, which will take approximately 17 months. The Orion spacecraft will meet it once it reaches high Earth orbit. Orion will take all 4 crew members and land them safely on Earth. Now let's take a look at the entire Mars flight epic in the grand scheme of things. The fact that spacecraft carrying astronaut to Mars will be launched from lunar orbit rather than from Earth or the moon itself makes the whole launch process much easier. Do you remember our example with the cabin at the top and the hiker indeed packing your backpack at the top? And traveling over flat terrain is much easier than hauling it up in one go. But there's one caveat: this life hack doesn't eliminate the vast distance that one still needs to cover. We can travel to Mars only at specific times when the planet is at a certain distance. After all, planets don't stand still, they move around the sun. And since the spacecraft will be traveling for many months, the Trajectory must be calculated so that both the spacecraft and Mars literally meet at one point in the shortest possible time. There are only two such windows of opportunity, and they imply different trajectories, namely conjunction class and opposite class. Conjunction class trajectory requires less fuel due to the use of convenient launch windows for the outbound and return trips. However, it requires a lot of time, around 900 to 1,000 days, with about 400 and 600 of those days spent on Mars. Opposition class trajectory, on the other hand, requires more fuel but reduces the expedition time to 560 to 700 days, and people stay on Mars to about 30 to 90 days. The difference in fuel costs is significant, more than threefold. Therefore, at first, NASA did not consider the opposition class trajectory as a viable option. However, in recent years, this perspective has changed. A new MT study of 2023 exclusively examines the opposition class mission concept for the first manned expeditions to Mars. It's crucial to reduce the risks of equipment failure and cruise radiation exposure, both of which increase with the mission's duration. In this regard, the opposition class expedition has a significant advantage. Interestingly, this trajectory involved performing a gravity assist flyby near Venus. It might even seem peculiar to get to Mars faster. One must fly to Venus, which is in the opposite direction, but that's how orbital mechanics work, sometimes quite strangely and unexpectedly. So now we have a full picture of how humans will conquer Mars in the future, both in general and in detail. The question remains, when will a living person set foot on the planet? At the time of this video's release, NASA's current announcement and forecast indicated that the Artemis program would reach its final stage with man landing on Mars by 2039. However, given the shifting timelines of Timus II, the actual date for a manned mission to Mars might be postponed much further. It's impossible to predict this. There are too many unknowns in this equation. One thing is clear: every step forward in the moon exploration brings us closer to the next big step for humanity, life on the red planet.